Let me start with a simple question. Is Kafka PubSub? Is RabbitMQ a queue? Is SQS a message broker? Hi there, welcome to Tech and Career Bytes. I'm a software professional with over 2 decades of experience, including 7 years in leadership roles at a global product-based organization. If you have ever been confused by these terms, PubSub, queue, and message broker, you're not alone.
Most engineers mix up three completely different layers: messaging pattern, infrastructure, and product.
And that confusion leads to poor design decisions. So, in this video, I'm going to clearly separate
What is a queue? What is PubSub? What is a message broker? And how production guarantees actually work.
by the end, you will stop asking, should I use Kafka or a queue? And start asking the right question. Let's start with the simplest concept, the message queue.
A message queue is a pattern, not a product. A pattern. It solves one problem: work distribution. Only one consumer processes each message. Once consumed, the message is removed from the queue.
Some of the use cases where a queue is useful are
Payment processing, email sending, image resizing, and background jobs.
now, here is the important point. In queue pattern, multiple consumers can compete for the messages.
If one crashes, another worker simply picks up the job. That is how queues improve reliability. A real world example is Amazon SQS. Amazon SQS implements the queue pattern.
Only one worker processes the message. That's the idea behind a queue. Now, let's contrast that.
PubSub is also a pattern. It solves a different problem: event broadcasting. Each service gets its own copy. No competition, no coordination.
That is how PubSub enables loose coupling.
A real world example is order created event. Many services like inventory consumer, analytics consumer react independently.
Apache Kafka implements PubSub behavior.
Notice the group ID, analytics group. This is different from inventory group. So Kafka treats this as a separate subscriber and it gets its own copy of every message.
That is what makes this PubSub. Now, here is the important clarification. Queue and PubSub are patterns. A message broker is an infrastructure that implements these patterns.
Some common message brokers are Apache Kafka, RabbitMQ, and Amazon SQS.
RabbitMQ can implement both queue and PubSub. Kafka can behave both like a PubSub and a queue, depending on how you use consumer groups.
PubSub behavior when different services use different consumer group IDs, and queue-like behavior if multiple consumers share the same group ID.
So, when someone asks Kafka or queue, that question is flawed.
Correct question is: do you need work distribution or event broadcasting? Pattern first, broker second.
Now, let's go deeper because this is where most systems fail.
Patterns define message flow. Brokers implement guarantees.
What does that mean?
It means the broker decides: can messages be lost? Can they be duplicated? Are they stored on disk? Are they replicated? And what happens if a node crashes?
But what do these guarantees and acknowledgements actually mean? Let's break that down.
Delivery guarantee means how safely a message reaches the consumer, whether it can be lost, repeated, or delivered exactly once.
There are three types of delivery guarantees.
At most once is fast, but message may be lost. At least once is the most commonly used. In this, message won't be lost, but duplicates possible. So your code must handle idempotency. Exactly once is the advanced level delivery guarantee. Here the broker tracks producer ID, prevents duplicate writes and coordinates commits.
Exactly once is not magic. It is careful configuration. Now, let's discuss ordering guarantees.
Ordering guarantees define whether messages are processed in the exact order they were produced.
In Kafka, ordering is guaranteed within one partition, not across partitions.
If ordering matters, like in payments, you must send with a key. Messages with the same key always go to the same partition. And since Kafka preserves order within a partition, they are processed in order.
Pattern did not define this. Broker implementation did. Let's see how acknowledgements work in a message broker.
If acknowledgement not sent, message is requeued and broker enforces retry.
Replication and durability are achieved by storing data across multiple nodes.
With replication factor set to 3, data lives on 3 brokers. If one crashes, system survives.
Pattern does not define durability. Broker does. Let's design a payment system.
Use queue pattern for payment execution. Only one payment processor. Use PubSub pattern for audit logging, fraud detection and analytics.
All implemented using a broker like Apache Kafka or RabbitMQ.
One infrastructure, multiple patterns.
That's how real systems are designed. Let's simplify everything we discussed.
At the top level, think in layers. First, the pattern, queue or PubSub. Next, the infrastructure, the message broker. And finally, the product, Kafka, RabbitMQ or SQS.
So don't ask, should I use Kafka or a queue? Ask instead, what problem am I solving?
If it's work distribution, use a queue pattern. If it is event broadcasting, use a PubSub.
Start with the pattern, then choose the broker. That is how experienced engineers think. If you found this video helpful, give us a thumbs up and subscribe to our channel for more interesting tech topics. Do check out our other videos on software performance optimization case studies, coding, system design, big data, and career growth. My name is Rupa, and I thank you so much for watching this video. See you next time.